Okay, so this is section 2, some more trig identities, and we're going to use our basic trig identities, our reciprocals, and the Pythagorean theorem identities that we saw in 7-1 in order to verify or prove additional identities. And a couple of rules when we're doing that. In order to prove or to verify, we can really only manipulate a single side. I can't cross-multiply. I can't use my properties of equality, adding or subtracting to both sides. I can start with one side and turn it into the other. I can do the other side and turn it into the first side, or I can work with both of them to turn them into a completely new piece. But the properties of equality don't apply here. So you can basically use any of your existing identities to manipulate one of the sides, as well as multiplying by 1 in any form, say sine over sine or cosine over cosine, or anything that you need to do. We just can't multiply, say, both sides by 2, or subtract 3 from either side. So when I look at the first one here, 1 plus cosine of x minus cosine squared of x over sine of x, this appears to be the most complicated side compared to the sine of x plus cotangent of x. So I'm going to start with the most complicated side and see if I can turn it into the simpler side. So I have 1 plus cosine x plus cosine squared of x. And what I'm going to do first is, whenever I see these squares up here and the constant's 1, I'm always thinking about my Pythagorean identities. So I'm going to manipulate this by bringing this piece over to here and switching this behind it, and just keep the sign. So I'm going to rewrite this as 1 minus the cosine squared, and I'm going to drop my x's or thetas or whatever symbol is using so it doesn't clutter up the page, plus cosine, and that is over sine. Now 1 minus cosine squared, if you look at your Pythagorean identities, that is equal to sine squared. So I'm going to replace that with the sine squared plus cosine over sine. And now we can essentially reduce or separate this as a fraction, sine squared over sine and cosine over sine, which is going to reduce it down to just a sine, and then a cosine over sine, which is the cotangent. So then I can put these back in, sine of x plus cotangent of x, and I see that that is the right-hand side as well. So that is verified, or I've essentially proved that. And that's all that we're doing with these identities right now. So let's look at the next example here in your notes. And this is just a simplify. Notice there's no equal sign, so I'm not trying to prove or verify anything. I'm just simplifying this down. And this is essentially a binomial, 2 terms in either, so I need to FOIL it out. So I have the secant minus the sine of x times the secant plus a tangent minus sine times tangent. Another helpful hint when you're working with these is start to convert all of them, once you've done this operation, into sine and cosine. So I'm going to change secant to 1 over cosine minus the sine times the secant plus the tangent, which is sine over cosine, minus sine times the tangent, which is sine over cosine. Now I begin to combine these, and I see right here I have a negative sine times 1 over cosine, so that's a negative tangent plus a sine over cosine, or a positive tangent, so these two will actually cancel. I'm going to get 1 over cosine, that's part of this here, minus a sine squared over cosine. And now since they have a common denominator, I'm going to write them together. So I have 1 minus sine squared over the cosine. And again, I have a sine or cosine squared and a constant of 1 out here. So this, I'm looking at my Pythagorean identities, and 1 minus sine is actually cosine squared. And cosine squared over cosine, this will all simply reduce to cosine. And then we can put our symbol back in this case, x. And moving down the page, let's look at another example. I am now asked again to prove. So again, this is what's called the left-hand side, right-hand side. I can work one at a time, turn one into the other, or turn them both into some third identity. But I cannot use my properties of equality in order to solve. So I'm going to go ahead and write this out. And another common thing when you have these in the denominator, notice I have my constant 1, but this is not a sign squared. So whenever I have that, I can always look to multiply by the conjugate pair. So 1 plus sine of x, and you'll see what that looks like here. So I'm going to do that to the left-hand side right now. So I'm going to take 1 plus sine over 1 plus sine. Remember, anything over itself is simply 1, so I'm not adjusting the value of this. That's what I meant when I said you can multiply by 1 in any form. And I'll multiply that by the cosine over 1 minus sine. So this then has to be distributed, and I get cosine plus sine times cosine over, and then I have 1 times 1 is 1. I have a negative sign, and then a 1 times sine is positive sign, so those two cancel. That's your difference of squares. Then I have a negative sine squared. And what that will oftentimes do for you is I've now taken 1 minus sine squared, and because I multiplied by the conjugate there, I now have one of my Pythagorean identities. And 1 minus sine squared, I can simply change into cosine squared. And now I see I have a cosine in either term here, so I can reduce out of both of those, and I have 1 plus sine over cosine, and I see that that is the right-hand side up above. And I could reduce this further if I needed to. I could separate this apart, and 1 over cosine is actually the secant, sine over cosine is the tangent, so I could change it to the secant plus tangent as well. But since this is the right-hand side and I've already met that, I've proven or verified that these two are equal. And the next one here, we have the secant of x plus tangent of x is equal to 1 plus sine of x over cosine of x. So you can pick a side. I'm going to work with this one, because this is already in terms of sine and cosine. So I'm going to change the secant to 1 over cosine, plus the tangent, which is the sine over cosine. Notice again I have a common denominator, so I can actually combine these two fractions, and I get 1 plus sine over cosine. And I see that that is actually what the right-hand side had as well. So I've verified or proven that these two are equal. I've shown the identity. So you're just manipulating one side or the other or both to a third identity in order to show that they are equal. So take a look at this one. And the first thing I'm going to do is I'm going to do the multiplication here. So I get a cosecant squared minus a sine times cosecant. So I've got my left-hand side, right-hand side. Right-hand side looks simplified already, so I'm going to leave it alone for now. I might have to make changes to it later, depending upon where I can get from here. I'm trying to work this perhaps to a cotangent then. Now that I've done the multiplication, I'm going to change this to its reciprocal identity, which is 1 over the sine squared minus sine times cosecant. And cosecant, remember, is 1 over sine. So this one will actually cancel here. And then I'm going to reduce this down to a 1. So right now I have 1 over sine squared minus 1, which doesn't really help me. So I'm actually going to take this back to the cosecant squared because we do have some Pythagorean identities with that. So I'm going to change it back to cosecant squared minus a 1. And if you look at your Pythagorean identities, you will see that this is actually equal to the cotangent squared. And so we were able then to manipulate this side or reduce it down in order to equal the right-hand side. So we've proven or verified this identity. We'll go down to the next one here. Almost done. And the first thing I'm going to do is I'm going to expand this into its sine and cosine. So I have 1 over the sine over cosine over sine. And the first thing I notice here is that I do have a common denominator in both of them, 1 over sine and cosine over sine. So I'm going to multiply the 2 by sine over itself, which is 1. So I get sine over sine, which will cancel out and leave me with 1. Then I have sine times cosine over sine, which will cancel out and leave me with a cosine. So this will actually reduce down to 1 over cosine, which is actually the secant. So certainly doesn't look like this. So now I'm going to have to actually manipulate the right-hand side and see if I can make some changes with that. So first thing, again, I'm going to do is take all these and express them in terms of sine and cosine. So I have the cosine over sine as the cotangent. Cosecant is 1 over sine minus sine. Now again, I notice that these all have signs in common. So I'm going to multiply the top and bottom by that sign. That'll cancel there and leave me with a cosine on top. That will be 1 times sine, which is sine over sine, or 1, minus sine squared. And if you look at your Pythagorean identities, again, I have a constant of 1 and a sine squared, so I'm looking at cosine squared. Reduce here, and you'll get 1 over cosine, which again is then the secant. And since I was able to change the left-hand side independent of the right-hand side and both to secant, I've verified or proven that those two are identities. And the final one we'll do here is I'm going to go ahead and manipulate this one. I selected the right-hand side because it was not in terms of sine or cosine, so I'm going to adjust this right-hand side. I'll put it over here. And I have 1 minus 1 over the cosine, and then 1 plus 1 over the cosine. So I again see that they both have a here, so perhaps I can look to cancel those. So when I do that, I get the cosine minus, that cancels, so I get 1. And on the bottom, I get the cosine, 1 times cosine plus 1 over cosine times cosine, which is 1. And I see that that then does look like this left-hand side here. So I've been able to adjust the right-hand side independent of the left and alter it using my known identities to look like the left-hand side. So, again, basic rule. Quality, you need to work one side or the other or both to a third reduction or simplification in order to verify or prove that it is an identity. Good luck. Bring your notes completed on Monday, and we'll get a little more practice.